In this lecture, we will be seeing another example of designing regular expressions for the given DFA when there are multiple final states. Till now, we have seen how to design the regular expressions when there are only one final state in the DFA, but here we see that in this DFA there are two final states. So we'll see how will we find the regular expressions for this kind of DFAs where there are multiple final states. So the process is very simple. We have to find the regular expressions for all the final states that we have, and at the end we have to just do the union of them. So let us proceed as we used to normally do. First we'll find the equations for the states that we have here. So here we have states Q1, Q2, Q3, and Q1 and Q2 are the final states. So let's first start with state Q1 and make the equation for Q1. Q1 can be written as, see the incoming transitions. We have one incoming transition coming from nowhere, which can be represented by epsilon, plus there is incoming transition from Q1 itself with input 0. So Q1 is 0, and there are no other incoming transitions to Q1. So this is the equation for Q1, and let this be equation number 1. And let's do the same thing for Q2. In Q2 you see that there is an incoming transition from Q1 with input 1. So Q1 1 plus there is an incoming transition from Q2 itself with input 1. So we'll write Q2 1, and then there are no more. So this will be equation number 2, that is for Q2. Now let's do the same thing for Q3. For Q3 we see that there are incoming transitions from Q2 as well as from Q3. So from Q2 it is coming with input 0. So Q2 0 plus from Q3 it is coming with inputs both 0 and 1. So Q3 is 0 plus Q3 1. So that's all for Q3. Let this be equation number 3. Okay, so now we have made the equations for all the states that we have. So now we see that Q1 and Q2 are both final states. So first of all, let's take one of the final state and find the regular expression for that. So let me start with final state Q1. First let me start with this. For that I will take equation number 1, that is for the equation for Q1. So Q1 equal to epsilon plus Q1 0. So this is my equation, and if you see this equation, we see that this is of the form R equal to Q plus RP, where this Q1 is my R and this epsilon is Q, and this Q1 right here, this is also R as we said, and this 0 is the P. So whenever you have an equation of the form R equal to Q plus RP, it can be written as R equal to QP star from Arden's theorem. This is from Arden's theorem, and so let me write it in this form. So this is R equal to Q plus RP, so I can write it in this form. So I'll write R, which is Q1, equal to QP star. Q is epsilon and P star, what is P? 0. 0 star. And also we know from our identities that epsilon into R is equal to R itself. So here we have epsilon into 0 star. So here my 0 star is the R. So epsilon into 0 star will be 0 star itself. So here I get the regular expression for my final state Q1. So let me just call this equation number 4. Alright, now we have finished solving for final state Q1, but we know that we have one more final state, which is final state Q2. So Q2 is also a final state, so we have to find the regular expression for Q2 as well. For that I will use equation number 2, which is the equation for Q2. So Q2 is equal to this one, Q1 1 plus Q2 1. Alright, now we see that we already found the value of Q1 to be 0 star. So I will substitute this value of Q1 in this equation. So this will be equal to Q2, and Q1 can be replaced with 0 star, and this 1 can be written as 1 itself, plus Q2 1. And how did we get this? This is by putting value of Q1 from equation number 4. Okay, now we see that this equation is also of the form R equal to Q plus RP. How? This Q2 will be R, and this whole term 0 star 1 will be Q, and this Q2 right here, this is my R as I said, and this one over here, this will be P. So this can be written as R equal to QP star by Arden's theorem. So let me write that. So R, that is Q2, equal to QP star. So what is Q? 0 star 1, and P star. So what is P? P is 1. So 1 star. So we are getting this. So this is the regular expression for the final state Q2. So we have two final states, Q1 and Q2. So when we have two final states, the regular expression will be the union of both the final states. So how do we write this? This can be written as the first final state was Q1, whose expression we got to be 0 star. So let me write 0 star. Union means plus. The second final state was Q2, and we got the expression as 0 star 1, 1 star. So this can be written as 0 star 1, 1 star. Alright, now let us just further simplify this. From here I see that 0 star and 0 star is common. So let me take 0 star common from this expression, and so I'll get here, I'll get epsilon plus 1, 1 star. Okay, and also in our identities we studied that epsilon plus R star is equal to R star. We studied this in our identities, if you remember. So here we see that epsilon plus 1, 1 star. So if you treat 1 as a regular expression R, so this whole thing can be written as 1 star. So 0 star, and this whole thing can be written as 1 star from this identity that we have already studied. So now when we perform the union of both the final states, the resulting regular expression that we get is the required regular expression for the DFA. So whenever you have more than one final states, find the regular expressions for all the final states and perform the union of them. That will give you the regular expression for the DFA. So I hope this was clear to you. Thank you for watching, and see you in the next one.